I'd like to introduce our next presentation, which is a MIPI Alliance Specification Roadmap, the wires for wireless, with Dr. Rick Wietfeldt of our Technical Steering Committee. Dr. Rick Wietfeldt serves as chairman of the Technical Steering Group for the MIPI Alliance. Mission is to drive MIPI's technology roadmap, and as senior director of technology for Qualcomm Technologies, where Rick leads the advanced technology, or the advanced connectivity technology group. Dr. Rick Wietfeldt holds a PhD in electronics engineering and is a well-known expert and spokesperson for technologies and trends in the mobile industry. Rick?
Thanks, Roy.
Yep.
Okay, well, it's actually made my job a little bit easier to talk a little quicker about some of these topics after Lindley's introduction, so thanks for that. In terms of, in trying to present this particular topic, what we tried to do was to present a little bit of looking backwards of where MIPI started out and relate it to kind of the mobile evolution, what we call the mobile Gs, the 1G up to 5G. And we tried to place kind of MIPI in the historical perspective of where it started and where it's moving towards. And the caption, the wires for wireless, is kind of an interesting story. It was kind of an interesting tagline that came up over the last year or so, really to try and illustrate the fact that any particular wireless technology is fundamentally enabled by wires, whether it be cell towers, whether it be our mobile devices. So that's really something that we're trying to kind of bring to light, that MIPI is all about the connections inside these end devices. In terms of the agenda, we'll start with a brief overview of this kind of history of MIPI from its inception, related to the evolution of the mobile Gs, talk about where MIPI is really focusing in terms of its roadmap, and spoiler alert, it's really all about moving, as Lindley described, into areas that are not really mobile terminals, but they're really heavily influenced by mobile technology, and in particular MIPI's roadmap. And then we'll conclude with, again, kind of an overarching idea for where MIPI is looking ahead. So even though this is the first developers conference, we're on to MIPI's 40-something meeting. MIPI Alliance started in 2013. A small number of companies came together, and the first kind of, if you like, the 0th meeting was in France, Sofia and Tivoli, and the meetings in earnest started in 2014. And you'll see that we're pretty much geographically centered, or very broadly, split across the 3 geographies shown. We have typically now 3 meetings per year in Asia, in the US, and in Europe. And you can see that we tend to, focus these meetings pretty much spaced regularly throughout the year. The Technical Steering Group, just a couple words. Essentially, our job in life is to drive the technology roadmap. Essentially, the way the group is organized is that every working group within MIPI has a member or 2, typically the chair, the vice chair, and in some cases, technical experts for those subject areas. And we meet at each member meeting for typically on the Monday, and we have a pretty packed agenda that Rob, Anhofer, and I run. And essentially, what our mission is to review the current roadmap, which I'll present an update for in a few minutes, and then to really try and stimulate the working group chairs to really think in a speculative way as to how they can evolve their particular technology. And I'll spend a little bit of time talking about that. We're increasingly working with the Marketing Steering Group to try and identify new opportunities for MIPI, again, towards pushing the roadmap forward. And to a large extent, even though the smartphone growth may be viewed as saturating, quite frankly, the technology in it is really needing evolution. We're already starting to talk about 8K displays for mobile terminals. and related displays. And cameras, we're now looking at 8K, 120 and 240 frames per. So the standard evolution of smartphones really driving a lot of these adjacent markets. So that's the technical steering group. This is a bit of a historical cartoon illustrating, that the first the first phone with a camera in it was apparently around 1999-ish. And then the first real data phone, which employed 2G technology at the time, was around the year 2000. And you see that was before MIPI was formed. And MIPI was really formed to meet the needs at the time. What were those needs? It turns out that the main silicon and OEM developers at the time really had their own proprietary interfaces. So we had parallel camera interfaces, various protocols for cameras, same story for displays. So really the very first kind of phase of MIPI was to organize those interfaces. And that was really the genesis of MIPI, was to kind of bring order to the chaos. And we actually sometimes think of those being the Wild West days in terms of being able to put together a mobile terminal, a phone. In many ways we see these emerging industries like automotive and things of that nature really being in kind of a Wild West stage as well, because if you look at the interfaces in a typical car today, there's still, it kind of looks and smells like the early days of smartphones where there's a lot of diversity. So we feel that there is an opportunity for MIPI and our partners to really do a good job to kind of coalesce these and optimize these. The evolution of the Gs, the evolution was working at a wireless company. We kind of live and breathe this on a daily basis. But 2G, the 1G is analog, and many of us remember those. The 2G was where digital data, we started to get data on the order of tens of kilobits per second. And you can see that as we move into mobile broadband and into the 4G all IP kind of paradigm, and then into 5G, you can see that dashed vertical line simply telling us that although it's shown as linear, it's really a kind of a log scale in terms of data rate. So really, truly for 5G, we're looking at tens of, 10 gigabit per second kind of scale, for the terminals. So we are very, keenly looking at what this means to MIPI and the interconnects inside the mobile device. And I'll talk a little bit more about that. I kind of find it interesting to look at the sizes of these phones. They started big. The trend was to go smaller. I remember my little Ericsson phone from around the 2000 era. And now, of course, they're getting bigger. And of course, I added in a kind of a wavy, smaller sized phone on the very right to indicate that, it's likely the case that not only phones will kind of go back to becoming smaller, not these big kind of slabs, but in fact, it does represent these smaller IoT-like devices that are not going to need to have large displays. So the MIPI team and I set out, not necessarily for this venue, but just as a kind of a fun exercise. We took a look at all the MIPI specifications, and there were over 45 or so. And we identified the specification release date. And what we did was we kind of put this in a graphical form, and really it's quite intuitive now that we saw the first camera phones and the resolutions needed to support it becoming the first focal point for MIPI. And you can see that the first phase of MIPI, if you like, these are not necessarily official, but kind of interesting talking points. In the first phase of MIPI, it was truly to kind of meet the demand for these smartphones, not necessarily smart at the time, but the multimedia phones, cameras and displays. And then as MIPI evolved over the next couple years, it entered what for now is referred to as a phase 2, where the rest of the specifications came into play. So these included things like the control and data interfaces, the first debug and trace interfaces, so kind of early days. And then in the subsequent phases, essentially these were kind of big waves, where all the specs really entered a phase of certain level of sophistication, and then thereafter it's growing. So when we look at the evolution, we see that it's really kind of a give and take. We're following very closely the mobile Gs in terms of the data rate requirements. But as I'll show in a minute, we really like to view the vectors that MIPI tries to follow as not only keeping up with the Gs, but also looking at the multimedia components, which really address kind of user experience related. So these kind of keeping up with the Gs is not the only focus that MIPI has. Certainly, a lot of the multimedia aspects of it are paramount to MIPI's success. This is another different perspective. The two kind of vectors that MIPI tries to follow now include the wireless Gs, so making sure that when a pre-5G phone comes over the next couple of years, that we have our portfolio in line, to meet those requirements. And quite frankly, those requirements are somewhat vague, because even though while 3GPP and other groups are working on 5G, how that translates into the requirements for a mobile terminal is maybe not so obvious. So from a developer's perspective, if you have ideas on how they may influence these, that's one of the outcomes we hope to get from the next couple of days. And then the other vector, if you like, is user experience, where many of the interfaces that we're familiar with, cameras, displays, audio, and storage, these are things that are now kind of taken for granted. But these two vectors are really advancing quite quickly as we kind of move beyond 4G. So this is the official MIPI specification roadmap. I'm quite confident that many of you have seen this. We've worked with Melanie and team to kind of, who's our marketing steering group lead, to put this together. We typically do this at our members meeting, but because this is the first DevCon, we updated it for this group. I'm not going to go through the details of this. They are captured in various segments or groupings, and I'll talk about that in a minute. I think the main takeaway from this chart is really one that it's a very busy one. We have 10 working groups or so working each on their own specifications, and it's really quite a busy time for MIPI and the members. And it's something that keeps the TSG, the Technical Steering Group, quite busy. Again, one of our fundamental jobs is not necessarily to invent technology. It's really to kind of keep MIPI's portfolio making sense from an adoption perspective, and to try and stimulate ideas in what we call speculative items from each working group. I'll talk a little bit about the groupings or the specification framework. So the mobile system diagram has evolved over the years, and what we've tried to, over the last few years, we've tried to capture the specification groups into four categories. One is the multimedia, which is in the upper left corner. The debug and trace in the upper right corner. The control and data, the typically lower speed interfaces in the lower parts, and then the chip-to-chip high-speed interconnects between the modem and the application processor AP, as well as to various accelerators that may be in the platform. So these particular specs fall into these four categories that we try and maintain. The multimedia are, of course, the cameras, the displays, and the audio. Audio is making a real, substantial, additions to the MIPI portfolio. And then UniPro, which is predominantly today used in the UFS storage standard. On the upper right, the debug and trace group is really taking it to the next level with gigabit trace interfaces that really need to support the really complex ICs that we have today, and really finding ways to standardize the protocols that one can plug a device into either physically or even through wireless means. So the gigabit trace group led by Enrico is doing a fantastic job to really kind of push the envelope to support these higher speed devices. Control and data. RFFE, I'm going to talk a little bit about that. Our RFFE is needed. Improvements to RFFE are needed to support some of the attributes of 5G wireless, and we'll talk a little bit about that. Some of the new interfaces that you're going to hear about over the next couple of days are the I3C for sensors and VGI, which is an interesting interface. It may be worth spending just a minute. Whenever one speaks of 5G, I know there's a lot of emphasis placed on the whole concept of, many gigabits per second, but there's an M-to-M, if you like, flavor, machine-to-machine flavor of LTE, which really speaks of, a megabps or lower megabit per second speeds. So what we decided to do within MIPI, there was an initiative brought forward to try and essentially to reinvent the UART, to make it possible to very simply connect these very low speed devices at low power. So that's a kind of a different angle to, to the 5G requirement. And then of course we have the high speed chip to chip interfaces on the lower. Now interesting is that those shown in red, it doesn't come across extremely well on this diagram, but those are the ones that are brand new specifications in 2016. So it's a busy time. Just a couple of minutes on layering. All the MIPI specs, literally all the MIPI specs are defined in terms of layers, not quite as quantized as the OSI layering, but essentially there's a physical layer of some type. We have the 3 high-speed PHYs, starting with D-PHY, and then M-PHY, and then most recently C-PHY. And then the protocol layers, and then the application. So what we've tried to do over the last couple of years, particularly over the last couple of years, is to really focus MIPI development, not so much on the interface, but on the application, which means, okay, if we're talking about a display, what are the attributes of the display? And that's how our marketing effort is really trying to focus attention on. Being engineers, we a lot of times think bottoms up. We're increasingly spending time kind of looking at the applications up top. So these are for the higher speed interfaces. The lower speed interfaces follow the same structure. In this case, there's not so much a SerDes in the PHY layer. It's more of a CMOS level type of PHY, character, but the layering is pretty much the same. So over the last while, we've been focusing a lot on meeting the performance needs in terms of the speeds of the interfaces. Power consumption has always been a big deal for MIPI. We're introducing low voltage swing and kind of race to idle type of paradigms with all of the interfaces. EMI has been a large topic for all of the interfaces. We're quite substantial studies to understand the slew rates and their impact on wireless interference within such a small device. So quite a lot of effort has been going on. Recently, we've added kind of a 4th pillar, which is essentially pins or I/O reduction. Very broadly, you can think of every time you save a pin on an AP chip, you can save on the order of ½ cent. And there's some give and take there. It can vary based on a number of factors. But if you imagine, essentially reducing pins through these more efficient interfaces, you actually get a lot of benefit from a lot of different angles. There's a lot of choice. As developers, one of the questions we always get is, geez, you guys have a complex roadmap. How do we choose which PHY to use? How do we choose which architecture to use? Well, in effect, the architectures are kind of AP-Centric, which is the kind of the hub and spoke model, which is represented in our current system diagram. But there's also the Unipro network-based architecture, which had been used in the Google Aura project. And that's encountering some challenges as they bring it to market. In terms of the PHYs, we have the 3 physical layers, and in terms of interfaces, there's a whole suite. So what I encourage you to do over the next couple of days is to really, listen to the individual topics and try and understand what choices you may have in implementing these. Lindley did a good job of introducing the opportunities in automotive, and in effect, we somewhat, jokingly refer to this as the biggest smartphone. In effect, a lot of the technologies are reused, and as a mobile, chip company, we typically can't afford to spin a chip that would cost $100 million or multiples of that for a very dedicated environment like a car. So all of our companies need to reuse. And that's really an impetus for MIPI to kind of extract new ideas to make new interfaces work in these new environments. So in terms of MIPI roadmap, very quickly, so MIPI is still all about mobile, but mobile is no longer just a mobile terminal. The two vectors that we're continuing to focus on, of course, are the wireless and, of course, the multimedia or user experience kind of vectors. That's really not changing. However, there is an increased focus on what we can do outside of mobile, or what we're calling mobile influenced. And it's all about the IoT and topics that Lily did a good job of kind of introducing. We are taking very specific actions within each of the working groups to try and ask the question, what can we do to enable other markets with our portfolio? And we're taking actions such as taking the physical layers like D-Fi and C-Fi and seeing what can we do to extend their length. So currently the smartphone or a tablet is about 30 centimeters. So what we're now exploring is how do we take it to meters length. So we may have a D-Fi or a C-Fi or an M-Fi looking at multiple meters, such that it's more applicable to a car environment, for example, or for a large, television, things of that nature. Some of the lower speed interfaces, RFFE, I3C, the VGI interface, we're all looking at different ways to reuse our portfolio to make it usable in these other markets. So in conclusion, MIPI has a fantastic current footprint. We're in every smartphone. As the feature phones evolve into smartphones, there's the full expectation that we'll be in all phones, period. And increasingly so as each device becomes more capable and needs to be more pin efficient, which is one of the big things that MIPI brings to the table. We're expanding, we're into these mobile markets, and we're trying to not only leverage but also optimize in the ways that I've described. So in terms of the DevCon topics, there are some general kind of discussions that you'll encounter. Very nice presentations on how MIPI is entering certain areas like automotive. There'll also be discussions not only on the high-speed interfaces, but on the low-speed interfaces. So with that, I'll conclude. In effect, what I tried to do is to give a little bit of history, but really to focus on what MIPI is looking forward to in the future. And really, as the first DevCon, what we're really looking for is assistance from the back end, from the developers, that really have to use these, and looking forward to feedback to see how we can do things a little bit better. So with that, I will conclude. I'll be around. We can have questions now or over the next while. So thanks.
Any questions? Any questions for Rick?
Do you know what percentage of tablets today use MIPI? Do you know what percentage of tablets use MIPI today versus EDP or something like that?
Well, it's a good question. It's a good question. Most cameras use CSI2. I think that's pretty much the way it works. MIPI is not alone in this space. I mean, Visa's display interface is a competitor, but we have a liaison with Visa towards that. So I don't know exactly, but whenever there's a radio in it, a cellular radio, you can be sure there's RFFE. And some folks, colleagues of ours, are working on bringing RFFE to the more Bluetooth Wi-Fi area. So I don't know the exact answer, but whenever you have cameras and displays, there's a high likelihood that it's MIPI. Some of the higher end laptops are going to use other things, but in terms of the more, it's a question of reuse. And it's really a question of the OEM, because certain OEMs have their own preferences. So those that we spend a lot of time with and who are attending MIPI generally are very positive on MIPI's evolution into these bigger devices.
Okay, one last one. On the displays, is there a particular display resolution where you want to shift from D-Fi to C-Fi?
The choice is a good question. So the choice between D-Fi and C-Fi it's an interesting question, and we didn't have time to go through it. There are presentations on those. It's not so much a display resolution choice. It's really, George Wiley from Qualcomm has a talk on it. It's really a question about, do you want to continue with a well-established interface through D-Fi versus something new that offers, at the very least, one big differentiator, which is a lower toggle rate. And the choice really depends on the OEM and their preferences. I know that there'll be more discussion on both of those interfaces, over the next couple of days. But it's not really about resolution. There are other things in play.
Any other questions? Down here?
Since this MIPI standards expanded earlier from mobile focused to mobile influenced applications, I wonder how or whether it would kind of make it a little bit different specification for application spaces, like EMI concern would be different from mobile to automobile or automotive applications than the specific kind of let's say a file standards would be different kind of relaxed or tightened depending on the application areas.
Right, it's a good question. How do the working groups in the TSG kind of look at these mobile influenced applications? It's really on a case-by-case basis. So, for example, when we look at I3C, it's one of the most popular demanded specs. I mean, we released the 0.8 version because there was so much demand. I3C in a mobile phone, for example, only needs to have a certain length. But that working group, the sensor working group, is looking at how do we go to 1 meter and maybe beyond. So everything is very delicate. I mean, we need to understand first, let's satisfy the mobile market. Every interface has different characteristics that need to be very carefully looked at. So I can't give you a straight answer, but only to say that every working group is looking at this. And there are changes. For example, when you don't have, when you have a bigger form factor, you may not care as much about interference because you have the antennas spaced farther apart. So it's a great question. I just can't give a very a good, simple answer. But every working group has this in mind as the roadmap progresses.
Anyone else? Back in the back.
So the MIPI interface standard is end-to-end, but as a system developer, the working group specify the different like insertion noise to the connector level, because the camera or display and the system that develop in the different house. So my question is, are we going to break out the spec to the connector? And the second question, are we going to standardize the connectors pins?
Right, so it's a good question. So the way MIPI does, short answer, because I know we're running a little bit late. Short answer is the way that MIPI does at least the PHYs is there's a link budget. So let's just pick a number. There's 20 dB of link budget. So whether the designer of the device chooses to put a connector in, that's their choice. They just need to assure that the link budget is satisfied. So that would mean potentially shorter traces. It may mean slightly more power to tweak the voltage higher. So MIPI doesn't go so far as to say, here are examples of how to meet your link budget, because there are so many designs out there. So really the spec defines a link budget, and it's up to the developer to really live within that budget, whether it's one connector or many connectors. Does MIPI explicitly have a plan to introduce connectors that are MIPI specified? No. There are discussions underway. I don't know to what extent we've discussed them publicly, but we are looking at, certainly the debug and trace group has created a specification for a connector. There is increasing interest because of the mobile influence kind of paradigm now to look at MIPI over certain connectors, maybe over USB, for example. But those are pretty early.
All right.